So in this tutorial, we are going to walk through the basics of how to create a staircase type design in PsychoPy. So staircases are most commonly used in psychophysics, where you might, for example, be looking for, say, the minimum level of contrast where a participant can see a stimulus. That's the example we're going to use for today's tutorial. However, staircases do have a range of uses. So if you're not a psychophysicist, don't worry. Hopefully this tutorial will still be useful for you. The first thing I'm going to walk you through before talking about anything in Builder is talk you through the spreadsheet that we pipe into our design here for a staircase. So here I have the spreadsheet that I'm going to use for specifying the parameters of my staircase design. In this tutorial, we're going to talk through using interleaved staircases specifically. Now, in theory, this can also be used if you just want one staircase. If you wanted one staircase, you would quite simply only have one row in the spreadsheet that I'm going to walk through today. However, it is useful to have two staircases. For example, if you're looking to better understand how well your staircases are converging. That is, for example, today we're going to look for the minimum level of contrast that a participant can see a stimulus. Therefore, we might start one staircase with a high contrast value, one with a low contrast value, and we hope that the thresholds from those two staircases meet at the same point. That is an indicator that the value we are getting from our staircase is actually useful and is kind of a reliable measure of this participant's perceptual performance. So in this example staircase, we have two rows indicating that we've got two staircases. And I'm just going to walk through the parameters of these from left to right, okay? So starting at label, this is just going to be how that staircase is indicated in your data output file. Now, here I've called one high start and one low start because I'm starting one of my staircases with a higher contrast value than the other one. In a staircase, NREPS is the minimum number of trials required in each staircase. Start val is going to be the starting value of our staircase. Now, remember here, I'm going to be adjusting contrast. In PsychoPy, contrast ranges between 0 being fully transparent, 1 being fully opaque. So my high staircase is going to start at a contrast value of 75%, 0.75, and my low starting staircase is going to start at a value of 0.25, so 25%. Moving on to the max and min vals of the staircases, this is quite simply to make sure that the level in our staircase doesn't surpass what's realistically possible. What we need here is we specify a list of step size values. What these correspond to is the change in intensity level each time my participant makes an incorrect response or an incorrect response. Essentially, what are we adjusting the intensity level, in this case contrast, by? It's typical to start our step sizes at something very large and then gradually decrease the size of those step sizes. This is because at the beginning of a staircase, it's very likely your participant might be quite far from their threshold. You don't want them to be stuck at that point that's really far from that threshold. You want them to be able to get down to a point that is close to their perceptual threshold relatively quickly. The other thing is that it is normal. Participants might make some incorrect responses at the start of the staircase because they're getting used to the task. This means that you don't want to change the step size to be too small too quickly, because let's say if we make an incorrect response, we have a large step size increasing the contrast of our stimulus. That incorrect response was just an error. If you're then stuck at a small step size, the participant's going to be stuck at that level that is really far from threshold. You can see in this example spreadsheet, I have 5 different step sizes. The step size progresses upon each reversal. It is worth noting that later on, one of the parameters we specify is n reversals. This is the minimum number of reversals required before your staircase will end or class itself as having converged and found a threshold. If you have fewer step sizes than reversals, then for the remaining number of reversals, you'll just stay at that smallest step size. Now, in terms of step type, in this example, I'm going to use lin, which is linear. If you are new to staircases, linear step sizes are going to make more sense to you when you're looking at your data and checking that your staircases are doing what you're expecting them to do. It essentially means the change in intensity that we expect to see as our staircase progresses is exactly what we've specified in these step sizes. The alternative we could use is log, which will be logarithmic step sizes. So the n up and n down of the staircase is essentially what's specifying the rule of your staircase. N up corresponds to how many incorrect answers do I need before the intensity of my staircase increases. N down is how many correct answers I need before the intensity decreases. You essentially want to check the literature for what threshold is it that I'm trying to derive. If I want a 50% threshold, I want to isolate the point where my participant is performing a chance, then I want to use a 1 up, 1 down staircase. A 1 up, 3 down staircase, I believe, isolates about the 70-75% accuracy rate. You might want to cross-check the literature on me there specifically. N reversals is the minimum number of reversals required before this staircase is classed as converging. Let's make the actual experiment where we feed that spreadsheet in. I'm going to add a text component, and I am going to make this text component last infinitely. And in the text field here, I'm just going to say $level and set every repeat. Now, level is a variable that is automatically generated by a staircase loop type. And this is what we use to manipulate a parameter based on level in our experiment. I also need a keyboard response. And for now, I'm just going to allow the left and the right arrow keys to be pressed. So now we want to add our loop type. What we want to do here, of course, is we're going to set loop type not to staircase, but actually we're going to use interleaved staircases because that's what's using the spreadsheet that I demonstrate here for you. Stair type, we are going to set that to simple, but you can use different staircase algorithms if you want. Switch method, we're going to leave this as random. This is essentially when you look at your spreadsheet, do you want those staircases to be selected at random, or do you want to work through them in a sequential order until sampling of those is complete and then go back to the start of your list? And then here I'm going to specify that I want that staircase. And I can see this is correct because it's got 2 conditions, 10 parameters, and the parameters listed there are the ones that we have just worked through. In my keyboard response, I do want to specify what is the correct answer because that's what allows our staircase to adapt its intensity level based on the accuracy of the response. Now, you probably want to set this from a variable or something like that. For now, I'm just going to say that the left key is always the correct response. So I've run my staircase. I can see that this first trial is that low start staircase because it's starting at 0.25. So this is the high start. I'm going to make the correct response again. I can see it's decreased by 0.2 because that's my first step size. Now I'm going to start making incorrect responses, and I'm hoping that both of these staircases start to increase. So now there has been a reversal. I'm expecting that the staircase rule, one up, three down, has kicked in. So I'm going to have to make a few more correct responses for this to work. So bear with me while I quickly run through this, then show you the data. I've had a run through now of that task. I will warn you, I was not a very good participant. I basically did just hit the keys as fast as possible to hopefully get my staircases to converge. But I'm going to show you how you would now look at the data. So first of all, you've got this column trials.label. On each row there, it will tell you which staircase was sampled on that particular trial. The next column I'd guide your attention towards is the trials.intensity value. This tells you the level of the staircase on each trial. So that's going to be what we plot in a moment to check everything's working as we expect. You also want to have a look at the trials.response column. This tells you if the participant was correct or incorrect on that trial. Trials.direction is also helpful because it tells you the direction of the staircase at that point in time. So you can see, first of all, we're starting the staircase. Everything's going down because I made that series of correct responses. Then everything starts going up because I deliberately make some incorrect responses, then down, then up, and so on. Now, each time this transitions from down to up or up to down, that is classified as a reversal. Just in case you were wondering how you apply that level value, I said in this example we were going to adjust contrast. So let's say, for example, just to demonstrate that, if I add a stimulus, let's in this case say a grating stimulus, and I'll just configure the parameters of that. So I've made a grating. The parameter of this grating that I'm changing based on my staircase is its contrast. So here I might say in appearance, contrast is going to be level, and that changes on every repeat. So you can apply the staircase level to any parameter of any stimulus that can change trial by trial. When it comes to setting the accuracy of your response, therefore, you typically use a code component in a staircase routine. For example, here it might be that I'm actually asking the participant to make a judgment as to if that grating is oriented left or right. So I might do the following: have a code component at the beginning of the routine, say, I have two possible directions, shuffle those directions, select a direction, save that direction to the data file, and configure what the correct response is. Save what the correct answer is to the data file. Correct my syntax error. And feed in the correct answer to my keyboard response instead of always saying this is left. Not forgetting to move the code component to the top, because here I'm making a variable that's required by my keyboard response. I also want to make sure to use this direction to update the orientation of my grating. So now I need to respond to the orientation of the grating. In this case, it's right. So let me make some correct responses. Okay. Now I'm going to start making some incorrect responses to hopefully make this easier. Okay, so let us know in the comments what other YouTube content you want. If you have any questions, please go to discourse.psychopy.org. Thank you for watching, and I hope that you enjoy using PsychoPy.